Welcome to the deep dive. Today, we're really digging into the source material you sent us. We're looking at this huge effort underway to try and restore some trust in digital media.
Yeah, it's a big one because, as the research points out, we all sort of feel it, don't we? You can't just assume a photo or a video is, well, straight from the camera anymore.
Exactly. The digital history where content came from, it's often a black box. We need a way to track it.
And that's the mission today, really. Pulling back the curtain on the tech, trying to make that history transparent. It's not just one thing either.
Right. The sources mention it's multi-layered.
That's the key. You've got signed manifests, embedded signals, even forensic analysis, all trying to piece together the content's journey.
Okay, so before we get lost in the tech, let's get some terms straight. Because when we say AI media, it doesn't automatically mean something bad, does it?
No, absolutely not. And that distinction, it gets lost all the time.
Yeah.
So first up, synthetic or AI-generated media. This is basically any content, image, audio, video that an algorithm created or, significantly changed.
So like a mid-journey picture.
Yep, that's purely synthetic. But it could also be a real photo someone just, say, color-corrected or upscaled using an AI tool.
Yeah.
It's not necessarily deceptive.
Yeah.
Just technology-assisted.
But then there's the other kind, the stuff designed to fool us.
And that's the deepfake. That's the specific subtype. Usually it's about making it look like a real person said or did something they didn't.
Faking faces, voices.
Exactly. It hits us right where we're vulnerable. We tend to believe what we see and hear from people we recognize. It attacks identity, trust.
And the tool we're exploring today to fight both the simple edit and the malicious deepfake is
Provenance.
provenance. It's simply the history, the lineage, the chain of custody for that piece of content.
So who made it? When? What device? What edits happened along the way?
Precisely. It answers, what happened to this media file before it got to me? Sounds great, like problem solved. But I remember reading a really crucial warning in the sources, something vital for you, the listener, to grasp.
Yes. The big caveat. Provenance proves the integrity of the record. It tells you if the documented steps are accurate and haven't been tampered with.
Okay.
But, and this is the key, it does not prove the factual truth of what's in the picture or video.
Right. You could have a perfectly documented video of something totally staged.
Exactly. Flawless provenance, completely fake event. Provenance is evidence about the process, not an oracle about reality itself.
Okay, let's unpack that process then.
Yeah.
How do we actually create this tamper-evident record, something that sticks with the file?
Well, that brings us to things like metadata, manifests, and specifically the big standard everyone's rallying around, content credentials, or C2PA.
C2PA? Coalition for Content Provenance and Authenticity. Sounds official.
It is. It's this industry group trying to standardize how you attach, sign, and then verify that provenance data.
The manifest, you called it?
Yep, the manifest. It's basically the logbook for the content, and it's secured using cryptography. C2PA defines how to make that work across different cameras, editing software, platforms.
The shipping log analogy in the sources was pretty good here, like a signed document taped to a package.
That's a great way to think about it. You see every stop, every handler. If someone messes with the log after it's signed.
Verification fails instantly. But why a whole coalition? Why can't, say, Adobe just do this?
Because of interoperability. Think about it. Canon, Sony, Adobe, Microsoft, Google, Meta, they all have their own systems, their own data.
Right, they don't naturally talk to each other.
Exactly. C2PA is the translator of the rulebook. It says, look, if you want the data from this Nikon camera to still be readable after it's edited in Photoshop and then shown on Facebook, we all need to use this agreed-upon manifest format.
Solves that coordination problem and what actually goes in the manifest.
Oh, it can be really detailed. Timestamp, the device it came from, who the author is, if they choose to share that, and a whole list of edits.
So you could see, captured on an iPhone, exposure adjusted in Lightroom, then maybe an AI tool was used for upscaling.
Precisely. That whole history can be logged as assertions in the manifest.
But, and this seemed like a huge but in the research, there's a massive problem. Metadata gets stripped.
Yes. This is the Achilles heel. You upload a photo to social media, send it through a messaging app.
Poof. The platform often strips out all that normal metadata to save space or for privacy.
And your carefully signed manifest,
Right.
that whole provenance trail,
Yeah.
It just vanishes, gone the second you share it.
So that raises the obvious question. How do you make that link, that connection back to the manifest actually last?
Right. If the metadata is gone, the signature is useless unless you can reconnect the file to it somehow. This is where durable binding, or sometimes called soft binding, comes in.
Okay, durable binding. So instead of just relying on that external metadata shipping log.
You need to embed something inside the media itself. Bake a tracker right in.
How is that done?
Two main techniques. The first one is really fascinating, invisible watermarking.
Okay, this isn't like the faint logo you sometimes see on stock photos.
No, this is totally different. It's a signal, a pattern, embedded directly into the image pixels or the audio samples. Humans can't see or hear it at all.
But software can detect it.
Exactly. That hidden pattern carries a small, unique identifier. And that ID points back to the full C2PA manifest, wherever it might be stored. So a platform can find the manifest even if the metadata was stripped.
The sources really highlighted the technical challenge here, though, that trade-off.
Oh, it's tough. The watermark has to be incredibly robust, right? It needs to survive, being heavily compressed, maybe cropped, colors shifted, all the stuff that happens online.
Especially with formats like JPEG that are designed to throw away data.
Exactly. Compression algorithms are trying to remove subtle signals like watermarks. But at the same time, the watermark has to be completely imperceptible. It can't mess with the quality of the image or the sound.
So, strong enough to survive abuse, but invisible enough not to ruin the content? That's a hard balance.
Yeah. It really is. It's a constant engineering battle, a signal processing nightmare, almost.
Okay, so invisible watermarking is one part of durable binding. What was the second technique?
The second is fingerprinting.
Right. This one doesn't add anything to the file.
Correct. Instead, it calculates something from the file. It computes a robust signature based on the content itself, often called a perceptual hash.
Like a unique ID based on the image's visual features.
Kinda, yeah. Think of it like a mathematical fingerprint derived from what the image looks like. Even if the image gets slightly compressed or resized, that underlying fingerprint often stays recognizable.
So you can match a modified file back to its original manifest stored in some database.
Exactly. If the core visual structure is still there, the fingerprint can help reconnect it.
So watermarking and fingerprinting together make that link much harder to break. That's a strong defense.
It is. But we also know, realistically, not all content is going to get labeled or watermarked, especially right away.
Right, so what do you do with a file that arrives with nothing? No credentials, no watermark?
Well, that's why we need the third layer of defense, detection. Or you might hear it called post-hoc analysis.
This is the pure digital forensics part, right? Analyzing the file itself to figure out if it looks fake.
That's it. You're not relying on any embedded signal or manifest. You use machine learning models to scrutinize the content for telltale signs of synthesis.
What kind of signs?
All sorts of subtle statistical artifacts. Maybe unnatural patterns in the pixels, weird lighting inconsistencies, noise that doesn't look like it came from a real camera sensor. Sometimes it's things like textures being cloned unnaturally in backgrounds, stuff a human eye might easily miss.
Okay, so that rounds out the 3 layers you mentioned earlier. The key takeaway for you listening is this structure.
Layer 1 is the declared truth. That's the C2PA manifest, what the creator or system claims happened.
Layer 2 is the embedded truth. The invisible watermarks are fingerprints that provide that durable link back to the manifest.
And layer 3 is the inferred truth, the forensic post-hoc detection that tries to figure out if a file is synthetic just by looking at its properties.
And you really need all 3 because none are foolproof on their own.
Absolutely. Detection is probabilistic. Watermarks can sometimes be removed. Layering increases the difficulty and cost for anyone trying to deceive.
What's really wild is how this plays out as an arms race, even as these defenses are being built.
People are already working on ways to break them. It's absolutely an arms race.
The sources mention research systems with names like warfare, specifically designed to attack watermarks.
Yeah, tools are being developed explicitly to find, remove, or even forge these invisible watermarks. You can never assume any embedded signal is truly indestructible.
And that constant battle, that potential for failure, feeds into a really worrying social dynamic. The liar's dividend. Can you break that down?
It's a nasty consequence. The liar's dividend happens when deepfakes get really good, and the tools meant to detect them sometimes make mistakes, maybe flagging real stuff as fake or missing actual fakes. When that happens, anyone caught on camera doing something bad can just dismiss the evidence. They say, oh, that That's just a deepfake. You know those detectors get it wrong all the time.
So they don't even have to prove it's fake. They just leverage the possibility of fakes and the known flaws in detection to create doubt.
Exactly. It gives them a dividend of plausible deniability, even when the footage is perfectly real. The tech designed for trust ironically provides an excuse to deny reality.
Plus, there's the issue of open source AI models, right? Not everyone is going to play by CTPA rules or embed watermarks if they don't have to.
That's a huge challenge. If models are open and decentralized, enforcing standards becomes much harder.
So with all these challenges, where are we today? Is anyone actually using C2PA or similar systems in the real world? What might you, the listener, actually see?
Well, adoption is definitely picking up speed. It's a massive coordination effort, but we are seeing movement.
Like where?
Okay, take TikTok. Since May 2024, they started automatically adding labels to AI-generated content uploaded from other tools, specifically by reading C2PA signals if they're present.
Huh. Okay.
And YouTube is doing trials too. They're testing C2PA-based labels, but focused on signaling when a video came directly from an unaltered camera, sort of a positive indicator of integrity.
What about on the creation side? Are the AI tools adding credentials?
Some of the big ones, though. OpenAI, for instance, now attaches C2PA content credentials to the images made by DALL-E 3.
Okay.
And then you have specific vendor solutions, like Google DeepMind's SynthID. That's a system that embeds its own invisible watermark into AI outputs images, maybe video or text.
And their tools can detect that watermark later.
Right. It provides reliable labeling, but it's mostly reliable within Google's ecosystem. C2PA is aiming for that broader cross-platform interoperability. SynthID is more of a closed-loop approach for now.
Got it. Now, these technical hurdles directly lead into some big ethical questions. We need to cover these impartially for you. Let's start with privacy.
Yeah, the privacy versus transparency tension is huge. Provenance, by its nature, collects and potentially exposes data, maybe your location when you took a photo, the specific device you used, your editing steps.
Which is great for accountability, but potentially dangerous for others.
Exactly. Think about whistleblowers, journalists in risky areas, activists. They need privacy. Exposing their device ID or location could put them in real danger.
So how do these systems handle that? Can you have provenance and privacy?
The goal is to support selective disclosure. A creator should be able to cryptographically prove the integrity of the edit history, confirming I didn't fake this, while hiding sensitive bits like their name or exact location.
Prove the process without revealing the person.
Essentially, yes. Prove data integrity while preserving anonymity where needed. That's crucial.
Then there's the other big tension, free expression versus regulation.
Right. If you start mandating labels for all synthetic media, does that stifle creativity? What about satire, parody, art, political commentary that uses remixing?
Yeah. Could slapping an AI-generated label on a political cartoon change how it's received? Or could platforms start automatically downranking any content that simply lacks credentials?
That's the fear. Overly broad rules could be abused or just create friction for legitimate expression, especially if platforms start penalizing uploads that don't have the C2PA manifest attached.
And this all points back to the adoption challenge, doesn't it?
It really does. These tools, C2PA, watermarks, they only really work if everyone plays along. The camera makers, the software developers, the cloud services hosting the content, CDNs like Cloudflare, are starting to adopt it, and crucially, the platforms where we view it.
It's a network effect. If one link in that chain doesn't support or enforce credentials,
the whole system can break down for that piece of content. It needs near universal buy-in to be truly effective.
So given all this complexity, the arms race, the ethical tightropes, what's the final takeaway for the listener trying to navigate this?
I think you have to keep coming back to that core principle. Content credentials prove the integrity of the record. They don't prove the factual reality of what's being shown.
That distinction is critical.
It's everything.
So, when you encounter content, you need to use those 3 layers we talked about. Check for a manifest, declare truth, see if tools can detect a watermark, embedded truth, and apply your own critical thinking and context. Maybe even look for forensic analysis if available. Inferred truth.
Exactly. Treat credentials as evidence about the process, about the file's history and integrity. Don't treat them as a simple true or false stamp about the world.
Okay, so summing up our deep dive for you today. Restoring digital trust isn't about finding one magic bullet. It's about building layered defenses.
The goal isn't a perfect, unbreakable system that's probably impossible. It's about raising the cost and difficulty of spreading misinformation or harmful fakes.
Making it harder to cheat, by providing traceability and accountability through that documented chain of custody.
Precisely. And that leads us to a final provocative thought for you to chew on.
Okay, let's hear it.
If these provenance systems become truly global, yes, they offer vital accountability. But think about it. They also create an incredibly powerful mechanism for logging and tracking the history of almost all digital content.
A massive surveillance potential, alongside the trust benefits.
Right. And the system must be designed to protect vulnerable creators, like that whistleblower who needs to strip all metadata to remain safe. So here's the tension.
Yeah.
Should platforms be built to automatically flag or even penalize content that lacks credentials? Or do we absolutely have to preserve a smooth, friction-free path for uncredentialed content to allow for dissent, anonymity, and maybe uses we haven't even thought of yet?
That balance between demanding verifiable history for safety and preserving open spaces for freedom and privacy.
That's the knife edge. How we navigate that tension between safety and freedom will likely define the entire future of this digital trust infrastructure.